Hey there, algebra students. Mr. Lawrence here, and I'm redoing video number 2. Yeah, I did it last night. And thanks to some of you, Maggie and Laura and Sean and Angela, who let me know there was no sound, I was able to get it fixed. So here comes video number 2. You never saw this one without sound, so you wouldn't even have known. All right, gonna add these polynomials or subtract them, combining like terms, right? Because of the negative there, this is not a distribution situation. Okay, I'm subtracting this quantity from the first one. Remember that there's a 1 here and I have to distribute it, right? It's actually a negative 1, I should have said. And so I'm going to distribute. And when I do, I'm going to get 3x squared plus a 5x minus a 7. And then I'll get a negative 2x squared, and I'm going to write them vertically this time. Won't do that every time. Plus a 5x and plus 5. Going to combine those like terms, get an x squared. If I have 3x squareds and I take 2 of them away, I'm left with x squared. Or 1x squared if you like. Some of you put that 1 in there. Plus 10x's and minus 2. There you go. All right, problem number 2, I'm going to do a little bit differently. It's addition. Going to combine like terms, same thing. I'm going to do it using the highlighters. Now, please don't wait for me to tell you to use highlighters. If you like the highlighters on this kind of problem, then you go ahead and use them. Okay, I'm not going to mandate that you use highlighters, but if you're waiting for me to tell you, that's just silly. You go ahead and you use a technique that works for you. As long as it's honest, who cares? All right, so I'm going to combine the yellow ones. It's addition. I don't have anything to distribute. So how many x squared y's do I have? Well, I have 12 here, and I have 12 here, so I have 24 x squared y's. Now I have a minus 5xy and a plus 6xy. That would be a plus xy, wouldn't it? Negative 5 plus 6. Remember, the variable could be something tangible. Make it pencils, make it quarters, whatever you want it to be. The coefficient, the number in front, only tells you how many there are. Now I have a negative 8y x squared and a negative 2. Oh, I think I wrote that one wrong. Those aren't like terms. Yeah, I think that's totally an accident on my part. I think it's supposed to be xy squared. Yeah, sorry about that. Xy squared. Good thing I caught that because they're not like terms otherwise. All right, so get my highlighter back in blue. Okay, so now I can go ahead and say I have a negative 8xy squared, negative 2xy squared, so that would be negative 10xy squared. None of these are like terms because the variables have to match exactly, including the exponents, and they don't. All right. Number 3 is a double distribution problem. Should be simple by now. Some of you stop doing this technique where you do 5x times the quantity of 2x plus 4. If that worked for you, why would you ever stop? You know, I might have stopped doing it, but that doesn't mean you should. If it works for you, please keep doing it. Now I'm going to distribute the 5x. And so I'll get a 10x squared plus a 20x. And here I'm going to distribute the negative 1. And I get a minus 2x minus 4. Now we're not done with this problem because we've got some like terms here. So we're going to have a 10x squared, a positive 18x because 20 minus 2 is 18, and a negative 4. And now we are done. Okay, number 14. I wonder if I gave myself enough room to do number 14. All right, first thing I have to remember is a negative exponent means to use the reciprocal. So let's see, I got a negative exponent on that term and on that term. So those terms will be switching from either the numerator to the denominator, like that, or from the denominator to the numerator, like that. So I'm going to rewrite it, and I'm going to get a 15. There's going to be a 25, x to the 4th, and then a y cubed, an x cubed next to it. In the numerator, I'm going to have a y squared, and then a y to the 5th. And then z to the 5th over z to the 5th. Now I'm going to simplify it in 4 steps. I'm going to worry about the coefficients first, then the y's, then the x's, and then the z's. So I know 5 goes into both 25 and 15, goes in 3 times and 5 times. My final answer will have a 3 in the numerator and a 5 in the denominator. My y's, y squared times y to the 5th, well the shortcut is to add the exponents, right? That'll be a y to the 7th. Denominator of an x to the 4th times an x cubed, that'll be an x to the 7th. And z to the 5th divided by z to the 5th, well, I could subtract those exponents or just cancel them out because the same number divided by itself is 1 as long as that number is not 0. So my answer is 3/5 x to the 7th y to, y to the 7th. Let me start again. 3y to the 7th over 5x to the 7th as long as x, y, and z aren't 0. All right, problem number 5, very similar. Let me see here. I'm going to ignore this -2 out front on the exponent first, and I'm going to worry about this x to the -4th. Worry about this z to the -9th and z to the -10th. So I'm going to rewrite everything. I'm going to get 8 over 2, and there's an x, and then there's an x to the 4th. There's still a y to the 16th and a y to the 12th. Notice I kept them over each other, so I didn't make a silly mistake. And then the z's are going to switch places, and the signs on their exponents will change. All right, so now I'm going to simplify everything I possibly can inside the quantity. So 2 is going into 8 4 times. So I'm going to have 4. My x to the 5th, or x to the 1st times x to the 5th, I can't talk. X to the 1st times x to the 4th will be x to the 5th. Y 16th over y to the 12th, well, that'll be a y to the 4th in the numerator, right? And here, all the z's will cancel except for 1 in the numerator, and that'll be the -2nd. Now, that's negative exponent means to use the reciprocal, so I'm going to flip this fraction. And when I do, I'm going to get x to the 5th over 4y to the 4th z, and that's going to be squared. And then finally, I'm going to square it. And x to the 5th times x to the 5th is x to the 10th. Hey, 5 times 2 is 10. When I raise a power to a power, I multiply the bases, don't I? Or excuse me, the exponents. 4 to the 2nd power is 16. Y to the 4th squared is y to the 8th, right? Because y to the 4th times y to the 4th, there'd be 8 y's being multiplied. And z to the 1st times z to the 2nd is z squared. And this is assuming x, y, and z don't equal 0. All right, number 6 is up here. I'm going to use that trick of a power raised to a power. So 2 to the 1st times 2 to the 3rd is same as 2 to the 3rd. And then x to the 4th times raised to the power of 3 would be x to the 12th. Y to the 1st to the 3rd power would be like that. And then z to the 2nd raised to the 3rd power would be z to the 6th. And of course, I should do 2 to the 3rd, which would be 8. And so my best answer, my most simplified answer, is this one right here. Okay, 2 more problems here. Now 7 and 8. They are not distribution situations because there is no addition or subtraction going on. I'm just going to multiply coefficients with coefficients. So like 5 with 2. I'm going to multiply x's with x's, y's with y's, and z's with z's. Okay? I'm going to do the same thing over here. I'll do my z's. I'm going to do my y's. Going to do my x's. And I'm going to do my coefficients. Remember, it's not distribution. It's just straight multiplication. Why don't you go ahead and pause the video and multiply those and see what my answers are. All right, here comes my answers. 10x squared, y to the 8th, z to the 5th. That one's done. Over here, I'm going to have 12. No, I'm going to have 24, aren't I? 3 times 4 is 12, but then times 2 is 24. I'll get x to the 11th, and then a -2nd. So 11 minus 2 would be 9. It's going to be x to the 9th. My y's are going to be y to the 8th, and my z's are going to be z to the 8th. Did you catch my mistake? I said z to the 8th, but that's a z to the 1st, so it would really be z to the 9th. Trying to trick you there. All right, that's it for tonight's video. Mr. Lawrence signing off. Have a good night, everybody.